Today we're going to be working on Unit 2, Lesson 5, which is writing equations of parallel and perpendicular lines. We did have a video lesson on this same topic last semester where we reviewed the basics of parallel and perpendicular, and then the second part of our notes was writing equations of lines that are parallel or perpendicular and that pass through a specific point. Today we're going to skip the basics and just go right to the Math 1 side of it. But if you do need to revisit that old lesson, it was Unit 5, Lesson 5 in the Foundations of Math 1 folder or playlist. All right, so let's start out by just adding a few notes that we already have. So this is review. Parallel lines have the same slopes. All right, and we are going to focus these first two examples on parallel lines. So I did teach you both how to write the equation using a picture as well as how to just do it algebraically. And there is no right or wrong way to do it. Whichever way you prefer is completely fine to use. So I'm going to start with the graphing method first, and let's go over our steps here. Step 1 is to plot a point or plot the point that they give you. Okay, so let's go ahead and do step 1, plot the point. So I'm going to go +3 and then down 1, 3, -1. That is the point that they gave me. Step 2, find m from the equation that they give you. Find m from the equation. That should be an m. So sometimes you can look at the equation and identify the slope really easily, and sometimes you need to do a little bit more work. So let's go ahead. We've got to do some extra work for this problem. I need to put it into slope-intercept form first. So let's go ahead and add this to x to both sides. Bring everything down. Remember not to combine these because they are not like terms. And then my last step is to divide by 3, or -3 rather. And so my slope is -2/3, and 9 divided by 3 is 3. So -3. So that's my equation in slope-intercept form. But let's identify the slope that I will use. The slope I will use, because they want me to write a line that's parallel, I need to use the same slope. So my m for this example will be -2/3. So what I'm going to do is I am going to start at the point that I plotted, and I'm going to use my slope as directions until I cross the y-axis. So use m until you cross the y-axis, and when you cross the y-axis, you will find your y-intercept, which is b. All right, so let's do that. Starting at the point that I have plotted right here, I am going to go down 2, right 3. But remember how we can use different versions of our slope to change our directions? So I could also write this as +2 over -3, move that negative to the bottom. And so now that allows me to go up 2, back 3. And I have found my y-intercept right here. B equals 1. So what I will do is I will use the m and the b, and I'm going to write my equation. Y equals, plug in the m, negative 2/3, and plug in the b, which is a positive 1. And that's my final answer. The line that I just wrote is parallel to the original line that they gave me in the word problem, and it has the same slope. To ensure that it's parallel, I just had to find what the y-intercept should be. So that's how we can find the line, by graphing. Let's kind of switch gears and do that algebraically, okay? So the steps for algebraically still begins with this point, negative 2 comma 7, and what that ordered pair gives you is an x value and a y value. Then what you need to do is you need to look at the equation that they give you, parallel. So I'm going to look at that slope. Because they want me to find parallel, I will use the same slope that I see here. So my slope is negative 4. And now I'm ready, just like we were writing equations of lines earlier in this unit. Plug all the information that you know into y equals mx plus b, and you should be left with an unknown variable, which is the b, the y-intercept. So I'm plugging in my slope. My y value is 7, and my x is negative 2. And once those are plugged in, I'm ready to simplify. So negative 4 times negative 2 is a positive 8. Subtract the 8 from both sides. And now I know that b equals negative 1, which is my y-intercept. That was the part I did not know. And so I'm ready to write my final answer. So always have your y equals, bring down your slope, and then bring down your y-intercept that you just found. And that's your answer. Awesome. Let's go take a look at how we would do perpendicular lines. Okay, we're still going to practice with the same two methods, but this time we're going to be writing lines that are perpendicular. So instead of having the same slope here, we need to remember that their slope should be negative reciprocals. Negative reciprocals of one another. Okay, so negative, it doesn't mean that your slope will always be negative. What it really means is that whatever the slope is that you have originally, they want you to change the sign to the opposite. So if it started as a negative, I would need to change it to be positive. And then remember what reciprocal means. You're going to take your fraction and you're going to flip it upside down. All right. So if I had a slope that was just like a 3, how would you flip 3 upside down? So just remember, if you've got whole numbers or integers, you need to put them over 1. And that way, when you get the reciprocal, you can actually flip your top and your bottom so you can see what they are. Okay, so 3 over 1 and 1 over 3 are reciprocals, and they're not quite negative yet until I change the sign. All right, so now let's look at how to do this using the graphing method. So we're going to write the equation of a line that passes through this point. Okay, so again, what I'm going to do is I'm going to write my steps out to the side. Step number 1, again, is to plot the point that they give you. So negative 2, negative 1 on my coordinate plane is right here in quadrant 3. My second step is to find the slope from the equation that they give you. So we're going to find the slope. Now I am going to have to put this into slope-intercept form. So let's subtract the x from both sides. Bring down everything. Again, don't combine those because they're not like terms. And then let's divide everything by a -4. And if I simplify and reduce everything, I get y equals positive 1 over 4x plus 2. All right, now what slope will I use? Okay, so this is the slope, and they want me to write a line that is perpendicular. So what I need to do to this slope is to change the sign. Let's try to spell that word again. And then flip the fraction, okay? There's two parts to getting a negative reciprocal. So I'm going to change that positive 1 over 4 to negative, and then I'm going to flip the 1 and the 4 so that it looks like that. All right, so I'm going to use -4 over 1. All right, now, so we found the slope. Our next step is to 3, use that slope again, just like we did up before, to find the y-intercept. Which is your b. You need that for your equation. So if I go down 4 over 1, I can do that again, but I am going to run out of my graph. Let me come down a little bit. So I'm just going to extend my graph a teeny bit. So this would be about 7, 8, 9, 10. And these are all negative numbers because I'm on the bottom side of my y-axis. Okay, so let's go down again. 1, 2, 3, 4, and over 1. And I land on the y-axis at -9. So I am ready to write the equation. So y equals, bring down my slope, which is a -4. If you want to leave it as a fraction, you can. But because it's over a 1, if you want to just write it as an integer, you can also do that. And there's my y-intercept, and that's the equation of my line that is perpendicular to the original line they gave me, and it crosses through the point -2, -1. Now let's go do the algebraic method. The algebraic method still requires, again, that you start by looking at this point. And the reason that you need to do that is because that is an x value and a y value that you now know. And then you need to look at the slope. And because they want me to write a perpendicular line, I need to flip this 2 over 1 so that it is 1 over 2 and make that negative a positive. All right. So I have m equals 1/2 is going to be my slope. And now I'm ready to plug these in to y equals mx plus b and solve for my b. So my slope is 1/2, my y is -9, and my x is -2. All right, so -2 times 1/2 is going to give me -1, and then add 1 to both sides. So I have -8 is my y-intercept. right there. So now I'm ready to write the final equation. So y equals 1/2 x minus 8. All right, so I'd like for you at the very bottom of your paper, there is some extra space that you can write in, and I want you to add this extra problem that I wrote here. Are the following sets of lines parallel, perpendicular, or neither? We did cover this in our notes last semester. I just wanted to kind of refresh your memory on it, okay? So to determine if they're parallel, perpendicular, or neither, our main focus is simply on the slopes. So here I've got 2 and 2. Are these the same? Are they negative reciprocals, or do they not have any kind of relationship at all? And the answer is they're the same. So these lines are parallel. Okay, let's look at number 2. I see 2/3 and 3/2. Are those the same? And the answer should be clearly no. Are they negative reciprocals of one another? And this is where some students get messed up. They are reciprocals of one another. 2/3 was flipped. Now I have 3/2. But their signs did not change. So they're not opposite signs of each other, which means that they really don't have any kind of special relationship based on their slopes. Okay, so they're neither. And then for our last one, again, we're going to focus on our slopes. I have a positive 3/4 and a negative 4/3. So they are definitely reciprocals. Those fractions were flipped. And the one on top is a positive because there's no sign. And the one on bottom is negative. So these are perpendicular to one another. All right, great. Here's what I would like for you to do now. Our practice problems over here on the right, these are EOC applications. Let me go all the way to the top. So there are 1, 2, 3, 4, 5 problems that I would like for you to work out. Let's just cross out that 8. Okay, this is question number 5 here. It's up to your teacher if she would like for you to work by yourself or with a partner, but I do want you to pause the video and work on these 5 problems. And then when you're ready, when you think that you've gotten them all figured out, come back to the video, hit play, and then we'll walk through some of them together. Okay, so in number 1, I see the word parallel, which tells me my slopes should be the same. So let's find the slope from the line. This time they didn't give me an equation of a line like they did in my other examples. They just drew me the picture of the line. So we still do really need to know how to get the slope from a picture of a linear function, okay? So remember to find 2 good points, and then let's count our rise and our run. So 3/4 is going to be the slope. All right. So when we're doing an EOC, you can kind of go back and forth. As soon as I figure out one small piece of the puzzle on the right, then I can go to the left and say which answer choices would not represent parallel lines. So B has a negative 3/4. So that's not exactly the same. And then D has a negative 4/3. That slope is actually a perpendicular slope, not parallel. All right. And then, answer choice C also does not have the correct slope. It says 4/3. So really just looking at my slope was enough for me to figure out that the answer is A. But let's keep talking about this anyhow, just in case that it wouldn't necessarily get rid of all but one of your answer choices. So the second thing that we would need to do to find out for sure that the y-intercept should be at -2 is I would need to use my slope as directions to figure out where the point that goes through Q, or the line that goes through Q, where does it cross the y-axis? So 3/4, what I want to do to go left to get to the y-axis is I want to make them both negative. That's going to allow me to go left and then down. So I went left 4 and down 3. And then I crossed the y-axis right here at -2. So it didn't take that much extra work. All right, so my answer here is A. Number 2, which line segment is perpendicular to this line that they gave me? So here's what I definitely want to figure out to start out with is if this is the slope and they want me to do a perpendicular line, what slope am I looking for? So the slope that I would be looking for is positive 3/2. That's what I'm looking for. And then they give me all my answer choices are ordered pairs. So what I'm going to need to do is find the slope of each ordered pair. So this does require that you remember your slope formula. Let's just jot down here y2 minus y1 over x2 minus x1. That's going to be our slope formula. Okay, so for answer choice A, I'm just going to plug these in. Let's see, -4 minus -2, and then -2 minus -5. There's two negatives right here, so that should be a plus, and so should this one. -4 plus 2 is -2. -2 plus 5 is 3. So I have a -2/3. Is this the slope that I'm looking for? And the answer is no, it's not. So we've got to try another one. So let's do B. I'm just going in order. B. Okay, I'm going to do 7 minus -2, and then 1 minus -5. 7 minus 2, I'm sorry, 7 minus -2, that should be a plus, is 9. 1 minus -5 turns that into a plus, so I'll get 6. And then if what you get is a fraction that can be reduced, you do want to reduce it. So these are both divisible by 3. All right, and so I get 3/2. Does this match the slope that I am looking for? And it does. So this is my answer because these match. So my answer is B for this one. I didn't even have to go and try option C or D. You could if you wanted to, but once you find the correct answer, you can stop looking. Let's go do number 3. Line L contains the points -1, -1, and 2, 5. Line M is perpendicular to line L, and it contains the point 2, 0. What is the equation of line M? So there are two ways that you could do this. The first way is algebraically, or you could have done this the graphing method as well. Let's try, we're going to do algebraically first. So line L contains these 2 points. So what I want to do is I want to find the slope of line L. Okay, so line L, I'm going to do 5 minus -1 and 2 minus -1. 5 minus -1 is 6, 2 minus -1 is 3, and that reduces to a 2. All right, so that is the original slope of the original line L that I knew. Now let's figure out line M. They tell me that line M is perpendicular to line L. So if this is perpendicular, then I need to use M equals, let's change that positive to a negative, and remember that's over 1. So we're going to flip that upside down, and it will be 1 over 2. So now I know the slope. Remember when they give me an ordered pair, that is an x value and a y value. And I can take this information and plug it all into y equals mx plus b and solve for the b. X is 2, y is 0, and m that I'm going to use is -1/2. And these are being multiplied. Okay, so I've plugged all those in, and now I'm going to solve for the y-intercept. -1/2 times 2 is -1, and then you would have to add the 1 to both sides, so b equals 1. Okay, so based on my y-intercept of +1, I found my answer. And also the slope matches, the -1/2 that I was looking for, okay, is found in both options A and B. So C and D were already out because they were the wrong slope. Okay, and we said B is our final answer. All right, let's look at example 4. Example 4 says line segment FG has these endpoints. Which of the lines provided are parallel to it? So first thing I got to do is find my slope. The y value minus the y value is 9 minus 3, and now x minus x on bottom, and that gives me 6 over -8, and let's reduce that fraction. Both of these are divisible by 2, so I'll have 3 and -4. So I'm looking for -3 over 4. So this is -4 over 3. This is +4 over 3. This is +3 over 4. And the only one that has a matching slope, remember parallel tells me same. I'm looking for same. Okay, so A is the only answer choice that works. And finally, which statement is true about these two lines whose equations are given below? Are they parallel? Are they perpendicular? Do they coincide? Or do they intersect but they're not perpendicular? Okay, so let's see. The first thing that we want to do is solve them so that we can see what their slopes are. So let's do 3x minus 5y equals -3. And then -2x plus y is -8. And we're going to solve these both and put them into slope-intercept form. So subtract 3x, -3x minus 3, and 5y, dividing by 5. So I have y equals negative 3/5 x minus 3/5. My other equation, let's add these two x's to both sides. Y equals 2x minus 8. And there's no coefficient in front of y, so I'm finished. Okay, so the first thing that I want us to look at is, are these parallel, perpendicular, or neither? And these are neither. So they're not perpendicular and they're not parallel. Next, we need to determine if they coincide or if they intersect, but they are not perpendicular. We've already established that they are not perpendicular. So that part I know is true. But if I graphed these lines, would they intersect? Miss Brown, would your definition for coincide also be intersect? Because I have outwritten to the side here intersect, but the lines coincide and the lines intersect. That means the same thing. And we've already established that they're not perpendicular. I'm a little confused about the wording of this problem. Oh, coincide would be they lie on top of one another. Okay. Coincide. So I think C and D are right. It's okay, we'll figure it out. Come on, dude. All right, so here is what I'm going to do now. I'm going to graph these lines for us. So I've pulled up this graph, and I'm just going to quickly plot the points so that we can look at them. So if I graphed these two lines, I could definitely see that they do intersect and they are not perpendicular to one another. They're also not parallel. They just cross over each other at this random angle. All right. So I'm going to say that my lines intersect, but they are not perpendicular. Now, coincide, I kind of skipped over it. That's a tricky word. So coincide, the way that I would understand it is that you would have two lines that are directly on top of each other, like this. And if they coincide, then they would also have to be parallel. Okay? So it's not going to be C either. Alrighty, that is our lesson for today. Go ahead, there is a practice assignment posted for you on Google Classroom.